In this video, we're going to do part 2 of standard BF.4a, B, and C. So these are about finding the inverse functions or various topics related to that. So question number 5 says this shows the graph of f of x. For which restriction on the domain of f of x is its inverse a function? So what would be best is to pick out some points from this graph and make a table. So that's what I'm going to do first. So f of x, let's make a table of x and y values. And I'm going to put the vertex in the middle. So that is negative 6, 0. And then it's good to have a couple points on either side. Like negative 7, 1, negative 8, 2, negative 9, 3, for example. And then on the other side, we have negative 5, 1, negative 4, 2, and negative 3, 3. All right, so if we take those and we switch them around to get our inverse function, so remember, switch x and y is a big idea with inverse functions. So we get 3, negative 9, 2, negative 8, 1, negative 7, 0, negative 6, 1, negative 5, 2, negative 4, and 3, negative 3. What we look for something to be a function is that each x can only pair up with one y. So each x has only one y value that it goes with in the whole function. So I see for my inverse function, 3 goes with negative 9, and then 3 also goes with negative 3, and that's not okay. And then 2 goes with negative 8, and it also goes with negative 4. And then 1 goes with negative 5, but it also goes with negative 7. Because what happens is when this function f of x reflects over the line y equals x, which goes right through the middle of our graph, inverse functions always reflect over y equals x. And if I plot these points, I can see that as well. So 3, negative 9, 2, negative 8, 1, negative 7, negative 6, or 0, negative 6, and then plot these other points as well. You can see that this is not a function. It does not pass the vertical line test, in other words. So they're asking you for which restriction on the domain of f of x, our original function, is its inverse a function. So everything would be fine if we only had half of it. Like if we had this half, or if we had this half, or if we had, like in our table of values, like only this half of the table would be fine, and only the bottom half would also be fine, but all of it together does not create a function. We got to restrict it, in other words. And so the turning point of where this is a function or not a function is that vertex value of negative 6. Like that's where it has to be restricted. So the best answer choice is B. Where x is greater than or equal to negative 6 is an option where those values, when inverted, would still be a function. It's not saying that's the only option, but it is from the answer choices we are provided. So it's answer choice B. All right, moving on to number 6. It says the quadratic function p of x equals 1/2 times 2.06 x squared can be used to determine the potential energy in joules contained in a spring when it is stretched x inches. What is the meaning of p to the negative 1 of 100? And so what you want to think about is the original meaning and then in the inverse of that. So they said x inches and p of x is the energy in joules. So you want to think of p of inches equals energy in joules is what the original function means. And then you want to switch that because that's your x and your y. And I need to put, for example, speaking of y, I need to add a little y right there. So for an inverse function, you want to switch these two concepts. So you want to say energy in joules. I keep misspelling that word. I apologize. Energy, like a very basic way to think of it is P of energy equals inches. You're switching the x and the y very literally, and then look at what they've given you. So p to the negative 1 of 100. So that's the 100 is the energy. So you got to find the answer choice that gives it to you in that order. The amount of energy contained in a spring when it is stretched 100 inches is not right. We're looking for energy is 100. The length of a spring is stretched when it contains 100 joules of energy. Perfect. Answer choice B. It's not the initial potential energy of the spring, which is answer choice C, and it's not the initial length of the spring, which is answer choice D. You just want to pick the one that has the x and y values switched. All right, let's look at number 7. 7 says the table shows function h of x. The inverse of h of x, is the inverse of h of x a function, and why or why not? So what we can do is the same thing that we have been doing, is picking out, does each x value pair up with only one y value? So let's rewrite x and y and inverse the h of x. So 0, 1 will become 1, 0. 1, negative 2 is going to be negative 2, 1. 2, negative 3 is going to be negative 3, 2. 3, negative 2 is negative 2, 3. And 4, 1 is going to become 1, 4. So is each x paired up with one y? So I see that is not true. 1 goes with 0 and 1 also goes with 4. So no, it is not a function. So the yes answers are definitely out. But now we have to pick out the reason why. So no, because, and let's see, this original function looks like it was fine. Each x is different and goes with only one y value. So we could say no, and it's because the inverse function would not pass the vertical line test. It's not because of the original function does not pass the vertical line test. So it'd have to be A, because answer choice B would be right if it was talking about the inverse. So think about the inverse of the vertical line test is the horizontal line test. And so this one would not pass the horizontal line test. In other words, if you went backwards, like notice if I go backwards and say the y values have to go with only one x value, and that is not true. So it's definitely answer choice A. All right, question number 8 says the table shows a function where k is a constant. The function has an inverse function. What is a possible value of k? All right, so we got to switch x and y and take a look at what's possible. So we had negative 5, negative 4. Now I have negative 4, negative 5. I had negative 3, 3, so now I have 3, negative 3. I have negative 1k, so now I have k, negative 1. I have 1, 2, so I have 2, 1. And then I have negative 5 goes with 3. So a possible value for k. So let's see. We have, it says the function has an inverse function. What's a possible value of k? So you want to look at these options down here. Negative 5. So notice like negative 5 is already an x value. So we don't want negative 5 to go with 3 and negative 5 to go with negative 1. So that would not make sense. And then negative 4. So negative 4 is also already an x value and it goes with negative 5. So k can't be negative 4 or this would not be a function either. So that's out. Then 2. 2's already paired up with 1. So k can't be 2. So the only thing left is 6. And 6 would work because see if k equals 6, it did not have an x value that would be paired up with more than one y value, which is always what we're looking for when we're trying to make sure something is a function. Okay, so that is it for standard BF.4a, B, and C.